let's try another problem putting it all together. Here we have a 15 Newton force applied to a cord wrapped around a pulley. So the tension force is 15 newtons. The pulley accelerates uniformly from rest to an angular speed of 30 radians per second in 3 seconds. If there is a frictional torque at the axle, determine the moment of inertia on the pulley. So I'm looking for moment of inertia. So I could do I equals, well, if it was a point particle, I equals mr squared. Right? This is not. This is a pulley. The mass is all evenly distributed. Next, maybe I could look at this chart and see if they have anything that would work out in this one. All right? Well, what I could do is I could say, hey, the pulley looks a little bit like a solid cylinder. But if I look at it, is it exactly a solid cylinder? When I look at this diagram, and let me see if I can find it here. Where did it go? Ah, here we go. Well, it looks like there is a lip. So it looks like there's a lip here, right there. So not all of that mass is evenly distributed. So I cannot use I of a cylinder. Whoops, I can't spell. Equals 1/2 mr squared. I can't do that, but we're going to come back and check that towards the end. So the only way I know then to solve moment of inertia is torque net equals I alpha. Okay. Let's look here and see which forces are creating a torque. Well, on this one, I can extend my force line. There is my R. That force is perpendicular to the R, so I have a torque due to tension. Okay? That force would speed it up. Then it shows me the force of friction, or I have a torque due to friction is slowing it down. So that's the opposite direction. So that would be minus torque due to friction equals I alpha. Okay. I could plug some variables in. Well, I know this is force that is parallel to R minus, well, on this one, I know the torque due to friction. That's what I have circled here, a number. I'm looking for I, then I have to sign alpha. Well, here I know it says from rest to an angular speed in 3 seconds. Well, that's a pretty handy dandy equation that I could do the change in omega over t, right, because I have that. So now I should be able to plug in all my numbers. The force here was 15 newtons times by the R, which is 33 centimeters, but I need to convert it to meters, so 0.33 meters, minus the torque due to friction, which was 1.1 newtons times meters, equals I times alpha, and alpha was the change in omega, which is 30 radians per second divided by 3 seconds. So that's the same as 10. When I do all of these calculations, I end up with I of the pulley equals 0.385. The units for I is kilograms times meters squared. Okay. Well, how could I test out if this is right, or any idea? Well, it's kind of cool. We could actually look at I of the cylinder. And if I plug in my same numbers, if I plug in my mass of 4 kilograms and radius of 0.33 meters, okay, I end up with 0.218 kilograms times meters squared. So let's compare. Okay. This number is when it is a solid cylinder. Okay. Now the pulley here has a greater moment of inertia. You should know greater moment of inertia means the mass is more along the outside. And hopefully that looks like this. You can see again this ridge that goes around. Okay? And to me that ridge, it looks like they cut out some of the mass from this inside, so I have more mass along the outside edge. More mass along this outside edge, so this is where there's less mass. There's more mass outside of that yellow, so that's why I have more moment of inertia compared to the solid cylinder. So again, this is some stuff that you'll be looking at. Torque nets equals I alpha when you're trying to solve some problems on the quiz. So here we have another problem. It says in the same information, instead of a constant 15 Newton force, we now have a 15 Newton bucket hanging from the cord. Assume the cord has negligible mass and does not stretch or slip. Solve the alpha and the acceleration of the pulley. Well, I don't have that same information before. I do know the mass, I know those types of things. But what I need now, right, is I'm looking for alpha. So here I could do the same thing, that I could start with torque net equals I alpha. So on this one, what's causing the torque? Well, it's it's still just the force of tension there. So force of tension times R minus the torque due to friction, which we had in the previous problem, equals I times alpha. So we know, what do we know? We know R, we know the torque due to friction that was given in a previous problem, and we know I. But here's where I'm stuck. I have two unknowns. Now some of you may say, well, Mr. Jackson, we know force of tension. Okay? So let's see if we're correct. So here I know gravity is 15 newtons, and then I have the force of tension. So some of you may say, well, force of tension equals 15 newtons. Hopefully someone else can explain why that is incorrect. This is only true when the acceleration equals 0. But in this problem, if you had a bucket that you were holding and you dropped it, it is going to accelerate downwards. Okay? If I had to draw these as vectors, okay, let's give this another shot. So here, I have to have mg going down. And now how long will this force of tension compare to that? Well, the force of tension has to be less. Because if you think about it, force of tension and mg are in a battle, or a tug-of-war battle, over the bucket. Okay? Now I can see here the acceleration is going down, so that means my downward force has to win, so the downward force has to be larger. Okay? But I still don't know what that is. So this is what we're going to do, is we're going to come up with an F net statement. Okay? I'll show you guys more later, but you really need to make whichever direction the object accelerates positive. So I know the bucket is going to accelerate downwards, so that I'm going to make it a positive. Okay? That matches up with tension, creates a, what's that, counterclockwise, so that's why we said tension is positive. Both of those kind of go together. Okay? So now let's do my F net statement. Okay? And here I end up with, I got to make down positive, so here I have mg minus force of tension equals ma. So what are my knowns and what are my unknowns? Well, I know mg, it told me that was a 15 Newton bucket. I don't know the force of tension. I know the mass of the bucket, because if I know mg is 15, m is 1.5, and I don't know the acceleration. So I have one equation, two equations, two different unknowns. Wait a minute, I have three unknowns. Now let's count those unknowns. Right. So here, one unknown, force of tension, two unknowns, alpha. This is still back to the same as my one unknown, tension, and I have my third unknown, acceleration. So if I'm going to do a system of equations here, I need to have three separate equations if I have three unknowns. So I'm looking for another equation. Okay. Well, which way could I have another equation? Well, I need an equation that relates A and alpha. Wait a minute, I know one of those. Angular times R equals linear. So here is my third equation. Okay? So I can merge these all together. Okay? So let's solve for alpha. Okay? So what I need to do, I need to get rid of A. So I could take this other equation that I have right here, right, and I can plug some things into this. So let's take this A and plug it in for that A. So my new FNet equation is mg minus ft equals m times alpha r. I've substituted in A for alpha r right here. So now, looking at my unknowns, I've gotten rid of the third one, so now I have to get rid of the second one. So I'm trying to solve for alpha, so let's get rid of force of tension. I'm going to solve this force of tension and plug it in over here. So if I had to do some algebra, I could say force of tension equals mg minus m alpha r. Okay? Like I said, I can take that and go all the way down and plug it in right here. Let me clean this up a little bit and let's do it. So Ft is mg, I'm going to need this mg minus m alpha r. Okay? Now I need to multiply by r, so this whole thing multiplied by r minus, okay, the torque due to friction, which I already know, equals I times alpha. Okay? This time I'm actually going to pause it and plug some numbers in for you. So here's my algebra. Mg of the hanging weight, that was 15. M was 1.5, alpha I don't know, R is 0.33, the other R is 0.33. Okay. Simplifying 15 times 0.33 gives me 4.95. Simplifying 1.5 times 0.33 times 0.33 gives me 1.6. Again, pretty easy, minus the 1.1, and then equals the 0.385, which I solved in the previous problem. And I end up with an angular acceleration of 7.03 radians per second. Okay. So I have that. So now what I could do is then I could find A. Well, I know the relationship for A, or linear to angular. Okay. I know I can take any angular term and multiply by R and get the linear term. So angular times r equals linear. So I could take my 7.03 times 0.33 as my radius equals the linear. Okay. With this, I will get a linear term of 7.03 times 0.33, and I end up with 2.32 meters per second squared. Okay. Does that make sense? How in the world could this accelerate at such a low rate? Okay. Well, if we think about it, the pulley has tension, so it's going to slow it down. Also, what do I have to worry about? I have to worry about the force. Some of this force has to be used to rotate the pulley. Okay. That force means I don't have the same force pulling down or up on the bucket. So I'm okay that it is less than 10 because the bucket, I'm having to use some force to rotate that, so it's not going to fall at the same rate. Make sure, come to class, have some questions for after the sub is here. Good luck working on that quiz. Give it a shot. Hopefully you can learn from this. Come with questions. Write them down since it may be a couple days before I see you.